Hello, my name is Luis Murillo. I'm gonna talk about active cooling of optical transceivers. Definition: an optical transceiver is a small form factor SFP pluggable transceiver as shown in figure. The transceiver contains a laser diode that transmits data, and the ability to assure transmission of data depends on keeping the temperature typically below 70 degrees centigrade. Now I present a video about what is an SFP.
Hey guys, this is Jonathan with Cables and Kits, and today I wanted to spend a few minutes talking about transceivers. Transceivers? What's a transceiver? What does it do? Why do I need one? Well, over the course of the next couple of minutes, we hope to answer those questions for you, one question at a time. A transceiver is a modular interconnect device that facilitates bidirectional communication over various distances using various wavelengths over various forms of physical media. Sounds all pretty straightforward, right? Well, not really. In English, it's a small metal thingy that plugs into devices that allows them to talk over extended distances. So, why do you need one? Well, we have a rule of thumb here internally and kind of a guide that we give to our customers. So, if you're trying to connect two devices that's over about 6 to 7 feet, which would typically be outside of one cabinet, you likely need to look for a transceiver to facilitate that communication. So, which one do you need? Well, that depends on a couple of answers to a couple of different questions. What you physically have in your rack, and also what you have in your wall in the form of wiring. So we're going to take a little walk down memory lane, and we're going to look at the different form factors and also some of the different older legacy switches that utilize the various types of Cisco interconnect transceivers. So the first optical transceiver was introduced, the 2900 series, 3900 series switches. These were the older SC media types. These are called GBICs. GBIC stands for Gigabit Interconnect. They'll go right in the front, just like you'll find the newer Cisco switches. The next generation of switches, the Catalyst switches, the 3560, 3750 switches, used a smaller form factor called an SFP. An SFP stands for Small Form Factor Pluggable. Go figure, right? These smaller units plug right in the front, just like the GBICs do. The later generations, the X series, 3560X and 3750X, uses an SFP+. Same form factor, but this is an enhanced version. This will give you a higher throughput. So GBICs, 10100, SFPs will facilitate gigabit uplink communication, and the SFP+, the enhanced version of the SFP, will give you 10 gig uplink capability. So we spent a few minutes talking about the physical devices. Let's talk a little bit about the wiring or the cabling. Now this might be cabling that you currently have installed in your walls and in the plenum, or it could be something that you're going to install. What you're going to be faced with is two basic types of physical media. Now which one you need depends on how long of a distance you need to propagate, or like I said to begin with, what you currently have installed in your wall. Installing cabling can be costly, so you might want to try to retrofit your SFP to what you currently have installed. So you got the fiber optic cabling, which you're most commonly going to find. There's also copper cabling. Now copper cabling, there's only a few different types of transceivers that are going to use that. The GLCT is probably going to be the most common. But you're going to find OM1, OM2, OM3, and OM4 cabling. The fiber optic cabling is going to be far more prolific as far as your installations and what you're going to see in the wild. So to recap, if you're connecting two devices over a distance longer than 6 or 7 feet, you're likely going to need one of these babies. You'll find both the Cisco original and also Cisco compatible versions of every SFP we talked about here and then some on the cablesandkits.com website. Also, you'll find all these cables as well. There's a great amount of detail and specifications on our product pages, so you should find what you're looking for there. If not, we have a phone number. Feel free to pick the phone up, give us a call, shoot us an email. We'll be happy to answer any questions that you have. As always, with these or anything that you buy on the Cables and Kits website, it's a 100% satisfaction guarantee. If you don't like it for any reason, send it back. We'll give you your money back. Same day shipping to 8 p.m. Eastern Standard Time, and our famous lifetime warranty. Not only will we replace it, we'll give you an advanced replacement as well. Thank you, and I hope we've added value to your IT infrastructure.
Application: the traditional thermal solution for the SFP is currently passive, contain an interface material attached to heat sink that dissipate heat through natural convection. This option, however, has been found to have difficulty with rejecting heat into ambient environment for radio units in 5G systems. An active thermal solution that requires no maintenance and can cool hot spots below surrounding ambient conditions is thermoelectric modules (TAMs). This is a semiconductor-based device made from lead that has unique property to pass through electric current while causing high thermal insulating characteristics. As a result, a small heat pump is formed that removes heat from the control side to the hot side. It is commonly referred to as the Peltier effect. Ceramic substrates are used for heat spreading and electrical isolation to pass through current on each P and N junction element. A TEM can be as small as 2 millimeters, allowing it to operate in tight space constraints. Now I present a schematic of a TEM. I'll present a video about transceivers.
Hi, I'm John from Unix Plus. Today we're going to look at transceivers. Transceivers are also known as optics or GBICs, and they go from copper to optical cables. We're going to do a review from 1 gig SFP plus to 10 gig and 25 all the way up to 100 gig optics. We're going to take a look at the original SFP, SFP plus all the different packages that have happened in 10 gig over the time, including X2 and ZenePack and XFP. So come with me and let's take a look at some 10 gig optics. Let's start by taking a trip down memory lane. The first real commercial application was the ZenePack, which was developed by Cisco, and it was a larger form factor optic that allowed for more power to come through into the transceivers. You can see the size of the heatsink and how big it was. Current 10 gig optics still just use this small form factor. So they've dropped from a package that would dissipate 10 to 15 watts all the way down to 2 watts now in this small form factor. After the ZenePack, Cisco came along with the X2. X2 still had a really wide connector because you were using very slow speed parallel inputs, and inside here it had the multiplexer that would go from that wide bus down to a narrow serial connector. Back in the day, everybody still used SC connectors, which was a standard optic. As switches got more higher density, everybody moved over to the LC, which is the current connector everybody still uses. After the ZenePack, X2, came the XFP. And this was the start of a higher density optic that used a little bit less power. This is the first serial interfaced optic where you were going high speed in to high speed out. That was quickly followed by the follow-on from the 1 gig form factor, which was called SFP, or small form factor pluggable, to SFP plus, which was small form factor pluggable plus with a higher spec for 10 gig and 8 gig. This is all based on the original fiber channel optics of 1 and 2 gig, were the same form factor. Nowadays you have QSFPs, which look a lot like the standard XFP package. You can see that nobody really reinvents anything new here. The notching is slightly different, but what a QSFP is really doing is it's 4 of these optics tied into one. These have 2 common connectors. The first one is MPO, which really has 10 optical lines coming out of here. So you have a parallel cable of 4 going out and 4 coming in. You can get breakout cables from MPO, which go to 4 pairs individually. The latest technology is what's called the BD, or bidirectional. This is a Cisco 40 gig BD optic. BD combines all 8 signals into 4 separate wavelengths. So you're actually transmitting just like the MPO cable over standard LC connector now. And you're combining all 4 channels into one cheap, inexpensive optical cable. This is because when you purchase a connect in a data center, typically you have to pay for the number of cables that you need between your cages. So if you can run 4 signals running at 10 gig or 25 gig across one cable, that saves you a lot of money, especially when you're talking building to building at thousands of dollars per cross connect. So that's a quick review of the different form factors we have here. Let's go next and talk about frequencies and manufacturers.
Pros and cons. Pros: durable construction to operate in elevated temperature environments up to 120 degrees centigrade. A thermal solution with a high degree of reliability, be capable of removing heat generated by optical transceiver running in an environment where temperature can exceed 95 degrees centigrade. Cons: the efficiency of heat dissipation could change in extreme environment. The cost of the optical transceivers with this cooling solution could be more expensive. You should apply it in Ecuador. Nowadays, in Ecuador there is no implementation or use of 5G system, but it must be taken into account that to have a faster data communication will present challenge for critical components such as optical transceivers. They are installed in radio units to transmit and receive data from the base station. The temperature of the device for outdoor environment will increase due to a smaller form factor and no access to forced airflow, which will increase the heat flux density of the radio unit. This results in high temperature that exceeds the maximum operating limit of the optical transceiver, thus requiring an active cooling solution. I will present a video how to test optical transceivers.
In fiber optics, the reliability of the network is probably the #1 most important thing to network operators. This is why testing and verification are critical in every single optic that contribute to a network. This is even more of an emphasis for bleeding edge technologies, from 100 gig to 400 gig optics. Hi, my name is Patrick Beard, and I'm the Chief Technology Officer for Add-On Networks. In this video, I'm going to walk through the proper methods and practices used for testing our next generation optics, from 100 gig to 400 gig. Before we do our own in-house validation, we make sure that we qualify every part. We validate their data sheets and reliability reports, along with a detailed bill of materials review. With these documents, we do a 10-point inspection process, checking various data points that point to longevity issues in the field. Things like industry temperature cycling, shock vibration, and humidity and heat cycling. We store and log all this data in our Data Traveler system, which is our proprietary software system that tracks every one of our optics from raw materials to delivery. Then we move to our in-house validation process, where we run our 2,000-hour reliability validation. These validation and testing procedures are the same for both 100 and 400 gig parts. However, 400 gig optics do require additional advanced equipment for further testing. First, we use our Expo test devices to do a hardware validation, checking that maximum data rates are achieved and ensuring that we meet bit error rate standards. We then move on to optical validation with various multi-lane DCOs. With this, we can evaluate various optical characteristics, such as eye diagrams, extinction ratios, as well as signal-to-noise ratio. Finally, we do our own platform-specific compatibility validation, testing each and every transceiver in OEM environments to make sure that our optics are fully compatible with OEM systems. This is just a hint of the extensive testing that we do for each and every one of our optics. If you have any questions about our processes, or if you're curious about our optics, please check out our website and contact us today. Thank you so much for watching. Make sure you like the video and subscribe to our YouTube channel for more fiber optic solutions.
For conclusion, the thermal solution for transceivers cooling in an outdoor environment yields an optimal solution to maintain form factor and minimize latency of a remote radio unit. This cooling solution provides the size and the cooling accuracy needed to obtain peak performance for SFP under the more demanding data transmission requirements of upcoming 5G networks. Thank you.